Hello everyone. In my last video, I talked about the button, how to use it, and a simple circuit using the button. In this video, we'll be using the Arduino and some input pins to read if a button is pressed and then turn it on. This is useful because sometimes you might want to replace the button with a sensor, and now you can with this process. This will allow many different more variations in your circuits. Additionally, we will introduce the buzzer, a simple component that works much like an LED, and we'll use that as well in this circuit. For this video, we'll be using two circuits connected to the Arduino. One will be for the button and the other will be for the LED. So for the button, it's simple like we did last time. You have a 5 volts connecting into the button, and on the other side will be another wire that connects to a pin. Always remember as well to connect a resistor and connect the button to the ground. Otherwise you'll get random numbers of like high and low, which could randomly turn your LED on and off. I had the same problem and it took me a while to figure out. So once you have your resistor connected to the ground and one connecting to the 5 volts and the other wire connecting to the pin, it should be able to read when a button is pressed, and the 5 volts should connect to the pin. And then what should happen next is, once the Arduino reads that the second pin is receiving electricity, it will then send out electricity to the LED, which is a simple LED circuit, just an LED and the resistor connected to the ground. So that's it, and the code as well is equally simple, and we'll see that right now.
We're back at the Arduino program, and as you can see, it's just as simple. It's just a very small bit of code. We start off with a button pin and an LED pin, and also a variable called button state that we'll set to 0. And we set the LED pin for output because that will turn the LED pin on, and the button pin is input because I'll be reading from whether the button is pressed or not. And then in the loop, it'll just check. First we read the button state, which digital read button pin, and then if the button state is high, we turn the LED pin on, and if it's if it's off, then we turn the LED off. So it's really simple. Just when the button is pressed, the button state gets turned to high, which will turn the LED pin on. And you can also just change it. For example, if maybe you want the LED to be on by default, and when you press the button, it turns off. So if button state is equal to high, if button state is equal to low, LED pin is high, and if else, then it'll be low. So you can just do that. That will also work so that when it's not pressed, the LED will be on, and when you press it, it'll turn off. So really simple, and you can always just replace the LED with other objects and other components. Really simple, very easy to use. This is how you use digital read and how you use input pins to read if a button is pressed or not.
So now that you saw how simple it was, you can start replacing the components with others. For example, you can replace the LED with a buzzer, a really simple component that displays a noise when electricity passes through it. So much like the LED, there's a longer and a shorter pin, and the longer pin goes from where the electricity is flowing from. And if we just attach it there, you can hear a noise. And additionally, you can have both the LED and the buzzer to create a sort of noise and light whenever the button is pressed. So if I just shift the circuit to make room for the buzzer, you will hear that both the LED and the buzzer will turn on. And you'll also notice that the buzzer is a lot quieter. That's because the more components you add and the more resistance it's in the circuit, the less loud the buzzer gets, much like the less bright a light bulb gets. So that's it. That's the how to use a button and how to read from a button to turn things on and off. And in future videos, we'll use other sensors, not just a button, like a photo sensor and other sensors that you can use to turn things on and off. So that was it for the video. Thank you for watching, and in future videos I'll be sure to use more sensors and more outputs and more components that can become more practical for daily use that maybe you can use an Arduino circuit in your own house to fix a minor problem. So thank you, and I'll see you in the next video.